Hello everybody, welcome or welcome back to my channel. Today's video will be doing the next topic, which is factors influencing the rate of corrosion. So mainly we'll be seeing three factors. One is the nature of material, nature of metal. The next one would be the relative anodic and cathodic areas. And the next one would be the nature of the corrosion product. There's more factors like the surface area of metal, is it smooth, all of that's mainly focus on this. Okay, so the nature of metal. Let's start with the first one. Nature of metal. So one thing you have to understand that here they're considering the usage of two metals. So if the potential difference between both of the metals is high, that means the corrosion rate is high. So we should use the metals which are nearer to each other in the electrochemical series, so they will have lesser potential difference between them. So, and lesser potential difference means less. If the potential difference is high, means corrosion rate is high. Lesser potential difference means less rate of corrosion. I will take an example. So, for example, let's take iron and copper and iron and tin. Iron's potential difference is, SRP of iron is minus 0.44 and of that of copper is 0.34, and that of iron, again as I told you, minus 0.44, and that of tin is minus 0.136. So using the calculator, let's solve this. This is what's the formula? E cathode minus E anode. This is larger, so that will act as the cathode. So 0.34 plus 0.44, that's going to be 0.78. That's the potential difference. Okay, here 0.44, so this is large, this is going to act as the anode. This is the cathode. So 0.136 plus 0.44. That is good. 1 second. This is larger in positive, so that is going to be smaller in, so that's going to be the anode, this is going to be the cathode. So minus 0.136 plus 0.44, that is going to be 0.304 volts. The potential between which has larger potential difference, this one. So when we use this, the rate of corrosion is going to be high. So Fe will corrode faster in the presence of copper. How did I say Fe will corrode faster in the presence of copper? Why can copper corrode? That's what. See, this is smaller SRP, it will act as anode. This is larger SRP, it will act as cathode. As I told you, anode only will undergo corrosion, cathode will not undergo corrosion. So Fe will corrode faster in the presence of copper. Here also Fe is the anode, but here the cathode is tin. So iron will undergo lesser lesser rate of corrosion with tin compared to that of copper. That is the nature of material. Nature of metal. Nature of metal, when I say, you have to remember the potential difference. Just remember this example: iron and copper, iron and tin. Higher the potential difference, faster the rate of corrosion, as in this case, and lesser the potential difference, lesser the rate of corrosion. Next, coming to anodic and cathodic region. Let's take two cases. In one case, anode area is small, cathode area is big. In one more case, the cathode area is small, anode area is big. Generally, what we think, anode is susceptible to oxidation. So more anode, more oxidation, more corrosion. No. So then we choose this, but that's wrong. Actually, lesser the anode area, faster the rate of corrosion. Again, point to remember: lesser the anode area, more the faster rate of corrosion. So when we choose a metal for industrial purpose, you have to choose such a metal that is having high anodic area and lesser cathodic area, so the corrosion will not take place. That much only have to remember. The corrosion of the metal occurs faster if the anode area is smaller than the cathodic, and the cathodic area is larger. Now I'll give you an example. Same example I will take of, okay, I will take iron and tin, and I will take iron and zinc. SRP of iron is minus 0.44, SRP of tin is minus 0.136. I'm not by heart these values, I'm just seeing and writing the values. Iron is minus 0.44 and zinc is minus 0.763. What I am doing is, iron is the metal, I'm coating it with tin. Here iron is the metal, I'm coating it with zinc. Now the scenario is that by mistake one small piece I have forgotten to coat. In both the cases, in small coat I have forgotten to coat, which will be affected more. That is the thing. First of all, decide the anode cathode. Here this will be anode, which is larger in positive, will be the smallest in negative. This is the anode, this is the cathode. Again this way it's going to be, this is going to be the anode, this is going to be the cathode. So here, when small area is left to coat, that what does it mean? Less anode region, means that much of anode region is not coated, a very small region is not coated, and more cathode region. So this will undergo faster rate of corrosion, rapid corrosion. Here the anode is this is the cathode. So small cathode region is not coated. You should not see the size of the metal here, okay? You should not see the metal size and the coating size. No. I'm saying for corrosion to happen, that anode cathode difference should be there, right? So the area exposed of the cathode is less, and so this is more anode region. So it will undergo lesser corrosion. One is rapid corrosion at the small anodic area, and this is slow corrosion at the small exposed area of the iron. What did we see here? In the plating of tin on iron, if some areas are not covered or some pinholes are left, small anode and large cathode areas are formed, and then intense localized corrosion occurs in the exposed anodic area. In the zinc plating on iron gives an anodic coating to the iron, correct? Because zinc is acting as an anode. So if zinc coating peels off even at some points, the rate of corrosion of the iron is low because of the large anodic and small cathodic areas formed. What this hole I am drawing is actually of the iron which is exposed. Here it's acting as cathode. Here it is acting as anode. So here lesser anode, more cathode. Here lesser cathode, more anode. That is the difference. Hope you understood this. The next one is the nature of corrosion product. So very simple terms I'll tell you. Suppose on corrosion of iron we get Fe2O3. This is a non-stoichiometric oxidation. Fe2O3 will in fact further enhance the corrosion. It will not stop it. So one metal undergoing corrosion or oxidation on formation of metal oxide prevents the corrosion further. Let's see, this metal layer is there. This will undergo oxidation, so basically it's getting corroded. It will form a metal oxide layer on this. A metal oxide layer is formed on this, which will prevent corrosion of the metal surface, which is going to further prevent the corrosion. Example is aluminium. It will form Al2O3. Aluminium undergoes oxidation, develops Al2O3 coating. This has protective properties which prevents further corrosion. I will tell you. Iron, the SRP of this is minus 1.63 and this is minus 0.44. This, if compared to this two, this is acting as anode. Still, if I compare an iron and Al2O3, even though this acts as an anode, this will undergo lesser corrosion because of the Al2O3 coating. Aluminium SRP is minus 1.60, iron SRP is minus 0.44. So aluminium is minus 1.63 is lower than minus 0.44. So that will act as the anode. Aluminium acts as the anode. It should undergo corrosion technically when I am comparing with iron. But because of the Al2O3 coating, which is protective properties. It will prevent the aluminum from undergoing further corrosion, and so it is acting as a protective layer. That is one thing. Now we saw first we saw the nature of metal, where we saw the potential difference. Then we saw the relative anodic and cathodic area, where I said that lesser the anode region, more the cathodic region, means more corrosion. How can you remember? More cathode, more corrosion, CC. And then we saw just now the nature of the corrosion product. Other factors also include that the surface of the material, if the surface of the material is smooth and means not much cracks or brittles, then there is lesser rate of corrosion in that. If there is cracks, then there is more chance of corrosion. So these are the few factors affecting corrosion. You have to remember, first of all, the heading for what are we studying for factors affecting corrosion. One is the nature of metals which are being used in the relative anodic and cathodic region, and then is the nature of corrosion product. So if you remember consciously, then you will do it. Okay, thank you for watching. See you in the next one. Bye bye.